Hello everyone. So today we're going to take a look at this problem from the 27th Philippine Mathematical Olympiad area stage. So the problem is, let a, b, and c be real numbers satisfying a plus b plus c equals 1. If the minimum value of 21 times the square root of a squared plus 2 plus 4 times the square root of 7b squared plus 1 plus 7 times the square root of 9c squared plus 2 can be expressed as m over n, where m and n are relatively prime positive integers, find m plus n. So in order to solve this problem, we're going to use Lagrange multipliers. So it is an optimization technique in order to find the minimum and maximum of functions with certain constraints. So the constraint here is that a plus b plus c must be equal to 1. And we're tasked to find the minimum value of this expression. So I'm going to set up first. So let f of a, b, and c, so it has inputs of a, b, and c, be equal to the expression given. C squared plus 2. Now it has a constraint, so I'm going to let g with inputs a, b, and c also be equal to a plus b plus c minus 1, which is equal to 0, because a plus b plus c is 1. So I'm going to set up the Lagrange multiplier. So set up the Lagrange multiplier. So we have nabla f, which is equal to lambda of nabla g. So basically lambda here is the Lagrange multiplier. So in order to solve for lambda, we're gonna have to take the gradients of each of the terms of f. So calculating the gradients. So I'm just gonna take the gradient of f with respect to a. So this is gonna be equal to 21 times, well, using the chain rule, so the derivative of the inside is going to be 2a all over 2 times the square root of a squared plus 2. And this simplifies to 21a all over square root of a squared plus 2. Now I'm going to take the gradient of the third term. So df over db, this is 4 times 14b over 2 times the square root of 7b squared plus 1. And this further simplifies to 28 times b all over square root of 7b squared plus 1. Now lastly, the third term. So this is equal to 7 times 18c all over 2 times the square root of 9c squared plus 2. And this simplifies to 63 times c all over square root of 9c squared plus 2. So now we have these three gradients with respect to a, b, and c. We're gonna equate these three together with lambda. So I'm just gonna put it on the right side. So it's gonna be 21a all over square root of a squared plus 2, which is equal to 28b all over square root of 7b squared plus 1 equals to 63c all over square root of 9c squared plus 2, which is also equal to lambda. So these are the Lagrange multipliers. Now we're gonna equate the first and second term first. I'm just gonna call this term 1, term 2, and then term 3. So I'm gonna go here, and now we're gonna equate. So equating 1, 2. So this is gonna be 21a all over square root of a squared plus 2, which is equal to 28b all over 7b squared plus 1. Now we just do some cross multiplication, so this becomes 21a times the square root of 7b squared plus 1 equals 28b square root of a squared plus 2. Now we're gonna square both sides, so this is 441 a squared times the quantity 7b squared plus 1 equals 784b squared a squared plus 2. Now I'm gonna distribute this, so this becomes 441 a squared b squared, I'm gonna multiply by 7, plus 441 a squared equals 784 a squared b squared plus 2 times 784 b squared. So this will further simplify to 2303 a squared b squared plus 441 a squared minus 1568 b squared equals 0. Now I can take a factor of a squared out, so this becomes a squared 2303 b squared plus 441. I'm gonna put this term to the right hand side, which is equal to 1568 b squared. Now this becomes a squared equals this fraction. Now we have a in terms of b, but we have to do this for equation 1 and 3 also. So I'm gonna do this here. So equating 1, 3. So doing the same thing. So 21a all over square root of a squared plus 2 equals 63c all over square root of 9c squared plus 2. So we do the same thing. We do the cross multiplication and then squaring both sides. So this will end up to 882 a squared equals 7938 c squared. So a squared equals 9c squared. So a is equal to 3c. Negative 3c is also allowed here, but I'm gonna take the positive because it's likely that the minimum will happen that way. And it doesn't really matter if it's positive or negative, since in here, in the original function, it squared the term a, b, and c are all squared. So we're just gonna take the positive. So using this fact that a is equal to 3c, we're gonna substitute it back to g. So substituting a equals 3c into a plus b plus c equals 1. Now this becomes 3c plus b plus c equals 1, which is b equals 1 minus 4c. So we now have b in terms of c. Now what I'm going to do is plug this back into here, and also a equals 3c here. So now we have like this equation all in terms of c. So this becomes 3c, so 3c squared equals 1568. So b squared is 1 minus 4c squared all over 2303 1 minus 4c squared plus 441. Now this is gonna take a lot of algebra, but just cross multiplying the left and right hand side, we're gonna get 9c squared times 2303 times the quantity 1 minus 4c squared plus 3969 c squared, which is equal to 1568 1 minus 4c squared. Now, further simplifying this becomes 207.27c squared times the quantity 1 minus 4c squared plus 3969 c squared minus 1568 plus 1 minus 4c squared equals 0. Now we can solve here for the value of c. And just doing a lot of algebra, so I'm just going to put dot 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 here, and this will turn out to be 1/6. Alright. So just expanding the quadratic form here in 1 minus 4c squared, and then further simplifying. So c equals 1/6. Now from this, we know that a equals 3c, which is equal to 3 times 1/6, which implies that a is 1/2. And also b equals 1 minus 4c, so 1 minus 4/6. So this implies b equals 1/3. So now we have values of a, b, and c. Now these values will be substituted back into the original expression, and that will be the minimum. So 21 times the square root of a squared plus 2 plus 4 times the square root of 7b squared plus 1 plus 7 times the square root of 9c squared plus 2. So now we substitute a equals 1/2. So 1/2 squared is 1/4 plus 2, so that's square root of 9/4 plus 4 times 7b squared plus 1. So this will become 16/9 plus 7 times the square root of 9/4 also. Now this will be further simplified to 21 times 3/2 plus, so this is going to be 63/2. This is 4/3, so this is 16/3, and this is 3/2, which is 21/2. So all of this, when added together, this will equal 142/3. And since this is in lowest terms, 142 and 3 are relatively prime, and we're tasked to find m plus n. So m plus n equals 142 plus 3, which is 145. So this is our final answer.